All right, AP Stats. We're finishing up this packet with Part 5, describing distributions. All right, how to describe a distribution of quantitative data. So the AP Statistics exam is very prescriptive about how you describe distribution of quantitative data. So there's 4 things that you need to look for: shape, center, variability or spread, and then unusual patterns, outliers, clusters, gaps. So those are the 4 things: number 1, number 2, number 3, number 4. And we'll go through some examples of what a description should look like. All right, first let's define shape. Shape of a distribution is what it looks like: major peaks, clusters of values, and obvious gaps, right? So we've actually got some vocabulary that we use to describe shapes. Now, I use histograms here. But the same words will describe all the other distributions of quantitative data: dot plots, stem and leaf plots. So here are our vocabulary words to describe the shape: symmetrical, uniform, skewed left, skewed right, and bimodal. So let's go ahead and talk about what each of these means. Symmetrical means if I draw a line right in the center, both sides would look approximately the same, roughly the same. It does not have to be perfect, it's just roughly symmetrical. Uniform means that all of the bars are about the same height. All right, skewed left and skewed right means that it's skewed a certain direction, but it's not what you think. It's whatever direction the tail goes into. So we'll talk about that in a minute. And then bimodal means 2 peaks. All right, so looking at this, I want you to pick which one you think is the, let me go ahead and number these so you can answer the question on Edpuzzle. All right, which one, 1, 2, 3, 4, or 5, do you think is symmetrical? All right, I hope you said 5. All right, which one do you think is uniform? All right, I hope you said 4. Do you see how all the bars are the same length? Remember, this just has to be roughly or approximately symmetrical, roughly approximately uniform. So the bars don't have to be the exact same height. They can just be mostly the same height. And see, symmetrical, if I drew a line down the middle right here, the bars are going to be roughly the same on each side. All right, now skewed left and skewed right. I bet you can narrow down that number 1 and number 2 are the skewed graphs. So looking at it, remember I told you it's not the direction you think, it's actually the direction of the tail. So do you see how my tail's on the right, on this side? That means this is my skewed right graph. Do you see how my tail is on the left? That's my skewed left graph. Now the next packet we're going to talk about why these, why people keep coming in to say hi, so I have to keep pausing it. Lost my train of thought. Okay, next packet we're going to describe why the tail direction is what direction it's skewed. But just for now, remember that the tail of the graph is the direction it's skewed. All right, and then this last one is obviously bimodal because it has 2 peaks. There's a peak right here and a peak right here. This one, number 5, is unimodal, right? So it's got 1 peak right in the center. All right, I think we hit all of these. Box plots we have not talked about yet, but remember I promised you that I was going to do the Khan Academy work before I assigned it to you, and I realized that there are some questions on box plots. We're going to dive deep into box plots in a little bit, but for now, for this Khan Academy, it's super simple. When you're describing the shape of a box plot, it's either symmetric or not symmetric. So looking at this, you can see how there's no skew, or this is symmetric, because the line is right in the middle and both sides look relatively equal. Now, if the line is on the far right of the box or the far left of the box, you know that it's not symmetric. So on Khan Academy, all it says is symmetric or not symmetric, and you can easily tell just by looking at the box plot to see. Again, we're going to cover box plots in depth. Don't worry about that, but I just wanted to give you some tips for Khan Academy. All right. So that was shape. All right, center. The middle of the distribution. God, could your teacher make more typos in these guided notes? Median or median? This should say median or mean. Remember, these graphs are displaying quantitative data. And when we talk about quantitative data, we're talking about mean, averages, mu, right? Categorical data is proportions. So here, the center of the data is going to be either the median or the mean. Those could be two different numbers, or they could be the same number. So remember, the median is the middle number exactly, and then the mean is the average. Again, we're going to talk about calculating these in the next packet. I just want you to kind of know what the center is. All right, variability or spread. This is how spread out the data is, which makes a difference when we're interpreting it, right? So it's the extent to which the data points in a distribution diverge from the average, as well as the extent to which the data points differ from each other. How spread out is the data? Is it very spread out, or is it pretty centered? So looking at this, you can see that this is high variability. The distribution is spread out. This is low variability. The distribution is pretty close together, and this would be median variability. So the pieces of, or the statistics within a data set that qualify as variability or spread is the range. Remember, range is equal to the max minus the min. Interquartile range, the IQR, we'll discuss that soon. Variance we'll discuss soon, and standard deviation we'll discuss soon. I just want you guys to start associating these vocabulary words with variability or how spread out the data is. All right, outliers. Outlier is an unusual feature, right? It's not a typical data point. And it's a point which falls more than 1.5 times the interquartile range above the third quarter or below the first quarter. Don't worry about that specific definition right now. I just want you to get used to seeing what an outlier looks like. Do you see how an outlier is far away from the main cluster of data? So again, we'll be calculating outliers in the future. This is more to get used to like what the distribution looks like, okay? So this is the outlier. All right, my other unusual features, clusters and gaps. So a cluster is a large group of data points close to one another. So here you can see I've got one big cluster here, another cluster here, and then I've got one outlier right here. So if I were describing this, I would say I have a cluster at approximately 1 and a cluster at approximately 5. All right, I know that my document camera is going crazy. A cluster at approximately 1 and a cluster at approximately 5. All right, gaps. A gap is an interval that contains no data. I'm going to say that I have a gap at 3 here. Again, the outlier is something different. So I don't really have a gap of data in between 6 and 10 just because this is just one outlier. I have 2 clusters and a gap is in between a cluster. So I have a gap at 3. All right. Now let's talk about how to actually write this out on the AP exam on a free response. All right, so AP exam tip, always use context. Do not forget context. That's the easiest points that we can have referencing the question material. All right, so variable names and units are examples of context. All right, here's an acronym. Statistical opinions can vary. That helps us remember shape, outlier, center, and variability. If you guys can come up with a better one, I will give you extra credit because this one is not great. But still, stock of is what you can think of. Shape, outliers, center, variability. All right, example 6. Here's a dot plot of the highway fuel economy ratings for a sample of 25. So I went ahead and wrote the sample size out just because I want you guys to get in the habit of writing N is equal to 25 so you know that N stands for the sample size. So a sample size of 2018 Toyota 4Runners tested by the EPA. Describe the distribution. So I went ahead and noted a few things on this dot plot. I noted that the max and the min, so the min is 21.5 and the max is 23.3. I got that because I saw this is 23.0 and this is 0.5. So it has to go in order, 1, 2, 3, 4. I also circled this dot right here. We'll talk about that in a minute. Okay, so the first S stands for shape. So looking at the shape of the distribution, how would you describe the shape with the words we learned? Would you describe it as symmetric, uniform, skewed right, skewed left, bimodal? What do you think? All right. If you said symmetric. All right, so here is what we would write. Shape. The distribution of highway fuel economy ratings among 2014 Toyota 4Runners is approximately symmetric. So you could see I could draw a line right in the center, and about half the data is on either side, and it's approximately symmetric. Now that makes sense because we're talking about 2014 Toyota 4Runners. So you wouldn't think that they would be skewed a certain way, right? They're all the same car, so it should pretty much be symmetric. You should have the center, which is about the average or the median, and everything should be relatively close to that. Oops. All right, so our next one, O, outlier. So I just want you to be able to identify potential outliers right now. We haven't learned the calculation, so don't worry about that. But you can look and see that the max and the min are pretty far away from the group of data in the middle. So let's just say right now they're potential outliers. In the future, when you know how to actually calculate outliers, I want you to do the calculation and only mention true outliers. But for now, let's just say potential. So outliers, there are two potential outliers in the distribution at 21.5 mpgs and 23.3 mpgs. So my context point there was actually citing the unit, the mpgs. And you actually have to mention where the outliers are in the distribution. All right, next up is C. C stands for center. The two statistics that we can use for the center are mean and median. Hopefully you know how to calculate the mean and the median. If not, we're going to go over that in the next packet. But for right now, the median is easier to count in this distribution because with the mean, I'd have to add all the numbers up and divide by 25. But here, I know my distribution is 25, so my middle number has to be the 13th number. That's going to be the number right in the middle of the distribution. So what I did is I started at the min and counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I circled my middle number, and I know that it's at 22.4. So I'm going to say the median highway fuel economy rating is 22.4 mpgs. All right. And then V stands for variability. The only variability that we know how to calculate right now is the range. So that's why I wrote out the max and the min to the side like that. So let me go ahead and do a quick calculation. My range is going to be max minus min. So I'm going to do 23.3 minus 21.5, and that'll give me the range of the data. $1.8. All right, so I'm just going to go ahead and write the range of highway fuel economy rating is 1.8 mpgs. And I calculated that doing the max minus the min. And I got my context point by mentioning the highway fuel economy and mentioning the unit. So again, on a statistics free response, an AP statistics free response, if they ask you to describe the distribution, this is exactly what you're going to write. And you can even write stock of out to the left, and you can write shape, outlier, center, and variability. But you need to have 4 different sentences addressing these specific things. That's it. That's all it is. All right, so let's get some more practice describing distributions with different graphs other than dot plots. No, just kidding. I'll give you another dot plot. All right, describe the distribution of the dot plot below. Yeah, here directs a youth theater production who was looking at the ages of cast members. He was trying to describe the distribution. All right, we know it's a dot plot. We know it's quantitative data because we're talking about age in years, right? So what are the 4 letters that we need to write down to describe our distribution? Again, we don't have to go in this order. This was just the acronym that we have to help us remember it. All right, S stands for shape. How would you describe this distribution? Take a minute. I want you to go ahead and practice writing a sentence to describe the distribution. So I put the distribution of cast member ages at a youth theater production is approximately uniform. So it looks about the same for everything, right? Approximately uniform. All right, now with the O's, outlier. I don't see any outliers, and if you don't see any outliers, you need to actually state that. There are no potential outliers in the distribution. That way the AP reader knows that you actually checked for them. All right, center, remember we have two measures of center. We have median and mean. Right now it's just easier to calculate the median. We'll get into calculating the mean and putting it in the calculator next week. So looking at this, I want you to try and figure out the median on your own. So I calculated my sample size by counting the dots. There are 40 dots in total. Since I have an even number, I know that my median is going to be the average of the 20th dot and the 21st dot. But when I counted from the beginning, I got 20 and 21. They're actually the same number, so I know that my median is going to be 13. So I'm going to say the median age is 13 years old. All right, V stands for variability or spread. The only variability statistic we know how to calculate is range, so I'm going to say the range of the distribution is, we know my max is 18 and my min is 8. If I subtract them, I get 10 years. So the range of the distribution is 10 years. And that's it. We describe the distribution. This would get us full credit on an AP free response question. All right, so we have a couple more. Number 8, what kind of, I guess it's obvious, stem and leaf plot. All right, so here's the stem and leaf plot of math scores of 41 students. Describe the distribution. All right, so let's go ahead and write out our 4 letters. All right, S stands for shape. Well, this is a little strange, right? Because I typically don't, I don't know how to look at the shape of a stem plot. I've looked at dot plots that have a horizontal axis, and I've looked at, that's it, just 2 dot plots, right? Well, in order to figure out the shape of this stem plot, let's just turn the paper. So you can see I have 1 through 6, and you can see there's an obvious skew. My tail is this direction where it goes down. So do you think this is skewed left or skewed right? All right, I hope you said skewed left. So I'm going to say the shape of the distribution of math scores is skewed left. All right. O is outliers. All right, so looking at this, we're going to see that the notation represents, the stem and leaf represents 2 and 4, so 24. So math scores of 41 students. It looks like my first score is 4. My next 2 scores are 18 and 19. And then I keep going, 23, 24, 26. So I'm thinking 4 could be a potential outlier. We haven't learned the calculation yet. Don't stress. Let's just mention that there's a potential outlier. There is a potential outlier at a score of 4. I hope that's an outlier as a math teacher. All right, center. Let's go ahead and figure out the median again. So you'll notice that my N is equal to 41. So I have 41 scores total. So that median is going to be the exact middle number. And since my sample is odd, I'm going to have an exact median. So go ahead and see if you can figure out what the median is. All right, since the sample size is 41, then the exact middle number is going to be 21. So I went and I counted the 21st number. So I started here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I know that my center is not just 8, it's also the stem plus the leaf, so 48. So I have median of the distribution is a score of 48. All right, go ahead and see if you can write a sentence for the variability. Remember, the only thing we know how to calculate right now is the range. So I have the range of the distribution is 63. I took the max of 67 and I subtracted the min of 4, and I got 63. All right, I want you to go ahead and try example 9 all the way on your own. So pause that video and see if you can write the 4 sentences to describe the distribution of this histogram. This was a hard one to start you out on, so if you got frustrated, trust me, I shouldn't have released you on this one. Histograms are difficult because you don't have the underlying data, right? On example 8 and example 7, we had the actual data points. Here, we only have intervals, right? So the first thing I did is I put the frequency accounts above each bar. So I estimated them by looking at them. 1, 1, 11, 17, 15, 20, 24, and 10. And I added them all up, and it adds up to 100, so I know that I estimated correctly. All right, so starting off with S, this is the easiest one. You can see that I've got a tail to the left. So the distribution of the minting year of nickels is skewed left. O, I have one potential outlier. There's one potential outlier at the 1900 to 1910 interval. And I put 1900 to 1910, I shouldn't have done that. I should have put 1909. Because remember that interval really, like 1910 is the beginning of the next interval. All right, now here are the two tricky ones, the median and the variability. So C, the center. The median is in the interval between 1990 and 1999. So I found that out because I know my median is going to be the average of the 50th and the 51st nickel, right? So I started off here at 1. 1 plus 1 plus 1 plus 11 plus 17 plus 15 plus 20. So I go from the 46th nickel in the 15 bar to the 66th nickel. So that means I know that my 50th and 51st nickel have to be in this 20 bar somewhere. So I know the median is going to be in this interval between 1990 to 1999. And remember, I ended it the year before because this is the start of the next interval. All right, now the range is even more difficult than finding the median. So we can't calculate the range exactly either. We have to get an interval of what the range could be. So I'm going to pretend that the max is going to be my lowest max possible, lowest max, and highest min. This is going to give me my smallest possible range. All right, so my lowest max possible is going to be 2011, right? Because that's the, 2010. Because 2010 is the start of the new interval, 2010. Now my highest min possible is going to be 1909 because that's the end of this interval, right? We don't know what year this minimum is, and we don't know what year the maximum is, so I have to calculate a range for the range. Ha. All right, so I'm going to do 2010 minus 1909, and I know that that's a range of 101 years. So my lowest maximum range could be 2010, and my highest min would be 1909. Now let's do the reverse. Let's do the highest possible max, and we'll do the lowest possible min. All right, so my highest max could be 2020, and my lowest min could be 1900. This is going to give me my biggest possible range. So I'm going to do 2020 minus 1900, and I'm going to get 120 years. So my range is somewhere between 101 and 120 years. We don't know for sure. So I think I had a, there we go. My range of minting years is between 101 and 120 years. And we'll get more practice with this, I promise. I'll save the comparing for the next class to review this.